So today's presentation is serialization, Java serialization. So these are the topics that we are going to cover. So let's move on to what is serialization. Serialization is basically saving your object into an output stream. So basically you can save the state of the object to a file, for example, or send it to someone else through output stream, and then you can reconstruct the object later on. So maybe you can save a file, and that file could be saved for 10 years. In 10 years later, you can reconstruct the same object from the file. So the streams that are used for object serializations are object output stream for saving the object, in other words serializing the object, and object input stream is for deserializing, meaning reconstructing object instance. So in order to serialize an object, the class of the object has to be serializable type, meaning the class should implement serializable interface or inherit a class, extends a class that implements serializable interface. By the way, as you probably know, serializable interface is mark interface. It's just indicating that the class is serializable. It doesn't have any methods of its own. The class also should provide default constructor. A default constructor is a constructor with no argument. Now, most Java classes that come with the JDK are serializable, but some classes are not serializable, meaning those objects of those classes, the objects of those classes, some classes are not really making any sense to serialize. For example, thread. If you have a field, if you have a class that has a field that captured like a thread, current thread, serializing that thread field might not make any sense, because when you reconstruct it, the thread that you save it probably doesn't make any sense at all, because that's maybe 2 years ago. Okay, so there are certain classes that are not serializable for good reasons. If you try to serialize non-serializable object, you get not serializable exception. Okay, so what is preserved when an object is serialized? So basically, it should have enough information that is needed to reconstruct the object instance at a later time. So of course, the property values of the objects are preserved, meaning the state of every field should be preserved, because each object instance has a different value for those fields. However, the methods and constructors are not serialized into the stream. However, enough information regarding class is included in the output file, for example. So, for example, it will actually contain information about what is the name, full path of the class. Okay, so when you reconstruct it, if you do not have a class file, then you will have class not found exception. Okay. So the information should contain enough information to reconstruct it that includes class information, meaning the name of the class. Okay, so process of serialization. So you are going to use write object method of object output stream to serialize that object, and you pass the object that you want to serialize. Pretty straightforward. So this is example code. Suppose I have an object. In this case, I have a very simple object, which is a Boolean object, and in order to serialize it, you are going to create object output stream object. In this case, I'm creating object output stream object from a file called the boolean.ser. Okay, and then I'm going to pass my object through write object method of the object output stream. Pretty straightforward. And once you're done with it, then there should be a file called the boolean.ser. and that should contain enough information that is used to reconstruct the object instance later on. Okay, so this is the continuation of the code, nothing really particularly important. Okay, so this is the other part, process of deserialization. So you are going to use read object method of object input stream class. It will return, by the way, object type, so you have to typecast to the class that captures the actual class of that object instance. So this is an example. So suppose we have a boolean.ser file that we have created through serialization, and we are going to read that file through file input stream, and then we create object input stream here from that file input stream object, and then we are going to call read object method, and it will return object type. So you are going to, in this case, cast to boolean type. And again, this is the continuation of the code. We basically just compare whether the boolean object is true or not, because that's what we have saved before. Okay, so again, continuation of the code, nothing really important. Okay, so let's start our first demonstration. So in this case, we are going to save. Let's take a look at the code. We have what is called the persistent time. Let me maximize it. We have a persistent time class which implements serializable. It has a current time. It has actually date field. Okay, and when this object gets created, we just get the current date and time and save it. Okay. And the serializable time is basically just serialize that object. So we get the persistent time object here, and then we are going through the process of serialization. And deserialization is basically deserialize that object. Okay, so we are just saving it as the time.scr in the serialization process, and we are just reading that the file and then reconstruct it. Okay. Alright, so let's serialize it first. I'm gonna just run file of the serializable time.java. So it should create a time.scr file. Okay, and then we are going to deserialize it, and so you can see the previously serialized time, which is from the file, is the same. It's actually the just redisplay, so that should be the same. Okay, so pretty straightforward. Transient keyword. Suppose if you have a field that does not make any sense to get serialized. For example, if you have a field that maintains a current thread, again, that's not really making any sense to serialize it. Or in some performance reasons, there are some fields that you do not want to serialize because serialization and deserialization takes time. So you might in fact disable the serialization of serialization and deserialization for that matter for certain set of fields. So in that case, you can use what is called the transient keyword. Okay, so any field that is that is actually specified with the transient keyword will not be serialized. So let's see an example. So let's say we have a my class, and we have two fields. One is thread, and the other one is a string. The type fields, and we do not want to serialize these two fields. In that case, we can use transient keyword. Alright, so in this case, let's do the next demo, which is current time transient. So in this case, the persistent time.java file, we have the date. This time we are going to have that date field to be transient. Okay, so in this case, that date field will not be serialized. Okay, so let's try to serialized time and deserialized time is actually same as we have seen in previous demos. So run the file. So it is, even though it says current time is saved into time.ser, it actually is not serialized. If you try to run the file, you can see the previous serialized time is null. Okay, again, pretty straightforward. Version control. Imagine that you have create a class and then you create an object instance of it and then you serialize it into a file. Later on, you add a new field. Now, meaning you create basically a new class file. Okay. Now, what happens if you try to read previously saved serialized file? An exception will be thrown because actually let me explain that using the slide in the following slides. Basically, you will experience java.io invalid class exception. The reason is because every time you compile a class, meaning create a new .class file, a unique number will be given to that bytecode, to that class file. Okay, so in this case, when you serialize an object before, that should have a unique ID. Now, when you recompile it by adding a new field, it will contain the new serialized ID. It will have a new ID, so they will be different. So this is a way that Java knows whether a particular class is the same one or not. So in this case, when you add a new field, it will and then compile it, the class file will have a different ID. So that's the reason you get invalid class ID, invalid class exception, because they are considered two different class files. However, if you think about it, if you add a new field, you do not want actually old objects instance to just fail, right? Because there is nothing that actually cause and harm. So existing object instances that are saved into a file should be just recreated using new class.Maybe the newly added fields should be just null. Okay. So in that case, what you can do is that you can actually specify your own serial version UID. Okay. So the way that you can generate, well, first of all, you can just specify the number here by specifying the serial version UID field in your class. Okay. And in order to create the serial version number, if you want to create something unique, serializable version number, you can actually use a serial ver utility that comes with the JDK. So if you come with serial ver, then you can actually use this command that comes with the JDK. Alright, so let's do the next demo. So in this case, and let's see the version. Yeah, this is version control. So let's say we have persistent. Let's actually see the case that it fails. So I'm going to just comment this field out. Okay. So we save it, and we are going to we are going to just compile this file. Oh, it's automatically compiled because automatic compile on save is actually enabled in NetBeans. So now let's try to serialize it. Okay, so it is serialized, and then let's deserialize it. This should work because we haven't changed anything. Okay, now let's change this guy. We are going to add another field. Okay, so let's add another field, like field 2, something like this. Okay, and it's automatically saved. Now it's automatically compiled. So we got new class file. Okay, now if you try to deserialize it, it will cause an exception because the new class file that contains the new field has a different ID, serialized version ID, from the one that was saved in the file. Okay, so this is the reason why it actually caused this invalid class exception. Okay, So now, in order to solve that problem, we are going to now have serial version ID field like this. Okay. So again, it is saved and recompiled. Okay. So now we can do the same thing. So run the file and deserialize it. This one still should work. Okay. Now let's change, add a new field. So this time we will say 3. Okay, and save it. Now you should have been saved and compiled. So new class file has been created. So now if I try to run the file, meaning serializable time, it still should work because they are considered as the same class, because you now specify unique version ID on both classes. Okay. Okay, so hopefully that should be clear. Okay, customization of default protocol. Now, the read object method and write object methods of the object output stream and object input stream are actually default behavior. Now, if you want to have a different behavior from the read object and write object method of those two streams classes, you can actually provide your own read object method and write object method right in your class. Okay. So let's actually see the code. So let's see. We have persistent time, persistent animation time method. So what we want to do is, we want, when we see, this is actually, let's say, animation object, right? You know, what you want to do is that when you deserialize it, you want that animation to get started right away, okay? And that animation gets started from this constructor method, which contains the one single argument, and is basically calling this is runnable type, and it's actually starting it as part of the constructor, okay? Now, in this code, basically we are going to save it. So we serialize the object, and then we deserialize the object. Okay. So in this case, the constructor method of persistent animation does not get automatically invoked. Okay, which means it will not start the animation. In this case, the animation is just kind of displaying the message. Okay, so if you take a look at the code, we are going to create an object. Okay, so when we create an object, you know, because this is the first time we're creating an object, it will display this message: persistent animation thread is started. It will start that one. Okay, and then we serialize it and we deserialize it. Okay. Alright, so in this case, when we deserialize that object instance, it will not start the animation because the constructor method of that animation object does not get invoked right away. Okay, so that is the problem. So, you know, let's see the problem first. You can see, so we create the persistent animation object, and this method is actually this this statement is actually from the first time it gets created, and then we serialize it, and then we deserialize it. Okay, and you can see there is nothing happening from that animation object, meaning the constructor method of that does not get called. So this is the corrected code. So in this case, in our persistent animation class, we provide the read object method and write object method. Okay, so write object method is not doing anything special. It's basically doing the same thing of calling output object output stream, the default write object method. So we are not doing anything special in write object. However, when we read object, meaning deserialize it, we are starting our own animation. Okay, right? So when we are running this code, you can see there is a 2. This is the persistent animation thread is started method from the first time that object gets created, even before serialization and deserialization, and this is from after it is deserialized. Okay, so in this case, by overriding, actually no, it's not overriding, by implementing read object method in your persistence object, in your class, you are basically providing your own behavior. Okay, hopefully that clarifies this customization. Okay, so in our case, so what we have seen so far here is that we are writing our own read object and write object behavior of the stream classes. Now, if you want to have a total control, you can create your own externalizable the implementation. You can provide the implementation of externalizable interface. So basically, you are overriding, you are implementing write external and read external methods of externalizable interface, and basically you can do anything you want. Okay. So let's see. So what happens is the object serialization uses a serializable and externalizable interfaces. Okay. So each object, when it is getting serialized, it is checked whether it's externalizable interface type or not. If the object is externalizable interface type, then write external method of that implementation will be called. If it is not, then the normal, the method from the object upstream will get invoked. So in this case, this is in fact a bigger customization than the one that we have seen in previous case. In previous case, we are actually providing read object and write object method of object upstream and object inputstream classes. By using externalizable, you are in fact not even using object upstream and object inputstream classes. You are having total control. Alright, so our final demonstration is this read and writer. So code is relatively simple. If you take a look at this code, we are basically saving different type of classes. Okay, so one version that we are going to take a look at is my external object. Okay. So my external object. This is the one that we are implementing externalizable interface. Okay, so in this case, we are implementing write external and read external method, and here we can do anything we want. Okay, so here we are basically reading this int field and the string field, and then we are using the object output object type to write it out. Okay, and the other code is something very, this is basically using serializable, and this is again serializable, and this is doing some version control. Okay, so when you run this application, it should all work as expected. Okay, so basically this is my serial object. By the way, that the dialog box is just to get things going, and this is internal object and external object. So here, it does actually the right thing. Okay, so just read the right value. Okay, so that is the end of the presentation. So let me just